Hello. In this video I want to talk about the inverse function topic. If you notice in the inverse function folder under the lab manual lesson item, there is a Word document that was omitted from the lab manual. So it was a page that was omitted from the lab manual. So I want you to know that you're supposed to do it after you do the inverse function activity in the lab manual. So the lab manual, page 57, is the only inverse function topic in Module 2. So what was omitted was this document, which I uploaded to Blackboard, where it's asking you to find the inverse of given functions algebraically. So if we go back to Blackboard, that's what this Word document is. So let's talk about doing that for a second, because so far up to this point, we've just talked about a function and its inverse from a graphical perspective. We've talked how it's a reflection across the line y equals x. We've talked that the x and y coordinates between a function and its inverse are switched. So how do you find an inverse function given the equation of a function? That's what solving for it algebraically means. So let's look at an example. So here I have a linear function, y equals 3x plus 2. I'll call this f of x equals 3x plus 2. And using what we know about inverse functions so far, we want to find a function f inverse that reverses the points. So for example, let's pick 2 points from this function. When x is 1, y is 5. When x is 0, y is 2. Of course, there are infinitely more. So let's just find a function that gives us the reverse of these coordinates. So we want to find a function that gives us the point 5, 1, 2, 0, etc. So look what happens if you solve that linear equation for x. So I bring the 2 over, I divide by 3, and I get x equals y minus 2 over 3. So this makes y the input and x the output. So in effect, I've reversed my points, but to think in terms of the way we normally think, where x is the input and y is the output, I'm going to use this function, but I'm going to just interchange my variable names. So I'm going to call the input variable x and the output variable y, like we always do. It's no magic. I'm just renaming things because I realize that this is how I reverse the points. But in our world, the first coordinate is x and the second coordinate is y, so I'm going to interchange the variable names. So now look at the function x minus 2 over 3. When we input x equals 5, we get 5 minus 2, which is 3 over 3, which is 1. When we input x equals 2, we get 0. So we found our inverse function, x minus 2 over 3. So this is what we did. We solved for x. We interchanged the variable names, so we just renamed y x. There's no magic there. We did that solely for the purpose of reversing the x and y coordinates. And then we renamed y to f inverse of x. So that's how we find the inverse function algebraically. This interactive lesson starts off by talking about finding the inverse function, exploring it numerically. Then in the next page, it looks at what happens when you compose a function and its inverse, and how that builds up to finding a function and its inverse algebraically. So then when you get to do this page, you know what you need to do. You need to solve for x and then reverse y and x in the inverse function. Now, notice that these equations, these functions got a little bit more involved, not just linear functions anymore. You have rational functions, you have root functions. So that last Desmos function, Desmos lesson in our interactive lesson does talk about how you find these more complicated functions inverses algebraically. So make sure you go through that Desmos lesson to look at finding more complicated, finding more complicated inverse functions algebraically.